Inverse functions, quadratic, square root. One thing you need to pay attention to when you are looking at functions and their inverses is that a function only has an inverse if it is one-to-one. The quadratic functions, consider the basic y equals x squared or f of x equals x squared, is not a one-to-one function. Given a y value, say 4, there are two x values, positive 2 and negative 2, that will both get us that same result. So f of x equals negative 4 doesn't have a unique x value, which means that this function does not have a unique inverse. So in order to deal with that, we need to restrict the domain. If we decide that we want to look at y equals x squared only on the interval from 0 to infinity, then we are using just the positive branch of the quadratic function, and this is a one-to-one function. It will have an inverse. So we have to keep that in mind as we go through and solve to write expressions for the inverse of functions involving squares or square roots. But we can handle that, and we can look at something like f of x equals the square root of 3x plus 12. Right. This function, a square root function, has an implicit domain. The square root is only defined when the argument of the square root, 3x plus 12 itself, is greater than or equal to 0, non-negative. So the function we're looking at is only defined on values from negative 4 to infinity. And that's something that we're going to need to pay attention to when we look at the inverse of the function. But we can use the same trick that we use for finding the inverse of a linear function. I'll write this as y equals the square root of 3x plus 12, and then I'll swap my x and my y so that I have x equals the square root of 3y plus 12. Solve for y, first by squaring both sides of the equation, then subtract both sides of the equation by subtract 12 from both sides of the equation, and divide by 3. To get the inverse function in this case is going to be f inverse of x is 1/3 x squared minus 4. But again, we have to think about the domain of this function. And thinking about that can be easier looking at the graphs. Our original function, f of x, is the square root of 3x plus 12. Our inverse function, f inverse of x, was 1/3 x squared minus 12. And if we graph the square root of 3x plus 12, we get something that looks kind of like that. If we graph 1/3 x squared minus 12, we'll end up with a graph that looks something like this. Because the range of the original function was only positive y values and started at 0, we know that the domain of the inverse function should only use the positive x values. So this inverse function only works on the interval from 0 to infinity. For negative values of x, it will break down.